An ionic compound is a compound that dissociate in water and form ions. This means that when you add it to water, it forms ions. Like for example, if we're working with group number one, like sodium, like potassium in there, those they are completely soluble in water. Like for example, if we have NaCl and we add NaCl to water, then NaCl will turn into Na plus and Cl minus. These are individual ions. These are ionic form of the sodium chloride solid. Nitrates are water soluble. This solubility table you can have in the exam. Acetates, all form of acetates, no matter what the cation is, all form of acetates are water soluble. Chlorides are water soluble with the exception of these cations with the chloride. So if I have silver chloride, AgCl, AgCl is not an ion. AgCl is a solid. So all of these are going to form solids whenever they are coupled with the chlorine. So you would need this table, you guys, because you will be writing chemical reactions, single and double replacement reactions. So you know that whenever you form a product of AgCl, you know that it is not soluble, it is a solid, so you have to write it as a solid in there. All sulfates, these are soluble except the ones that are coupled with barium, strontium, lead, mercury, and so forth. Carbonates. Carbonates are insoluble in water. These are except carbonates in the group 1A and ammonium. So if we have sodium carbonate, for example, group 1A like sodium, potassium in there. So if we have sodium carbonate, Na2CO3, sodium carbonate dissociate into 2Na plus CO3 2 minus. Okay. Um, the phosphates, all phosphates are insoluble except phosphates for the group number 1A and ammonium. So if I have ammonium phosphate, this is soluble. It forms ions. Sodium phosphate, this is soluble. It does form ions in there. Notice like when I did the dissociation, I took into consideration the number of atoms, the sodium, how much sodium I have. Here I do have two sodium atoms. So when it dissociates into two sodium ions and one carbonate ion in there. So for the equation, so the equation for reactions that occur between dissolved material can be written in three ways. Either a molecular equation, total ionic equation, and net ionic equation. So for the molecular equation, you guys, it can be either a single replacement, a double replacement. These we already talked about in the first part of the chapter. So once you determine the molecular equation, here I can see it's a double replacement reaction. Then I'm going to write the total ionic equation. The total ionic equation represents all compounds or all substances in their ionic form. Okay, so in the ionic equation, whenever we're working with soluble ionic substances, these are represented by their ions that they form in the solution. Now, for the substances that do not dissolve or that dissolve but do not dissociate into ions, these are represented by their formulas. So let's have an example in there for the total ionic equation. Sodium chloride, this one is aqueous. Now I know that sodium chloride from up there. All sodium all sodium ions, these are water soluble, right? So when I say sodium chloride, this is water soluble. If it is water soluble, I need to show it as an individual ion in there. So that is going to be Na plus Cl minus aqueous, okay? And this one is going to be aqueous as well. Plus silver nitrate. Now silver nitrate, if I go up here, for the nitrates, all nitrates are soluble. So if they are soluble, then the silver nitrate is going to change into its individual ion when it is dissolved. So that is going to be Ag plus aqueous plus NO3 minus aqueous. Last time we agreed that the term aqueous we use whenever the compound is dissolved in water, then we use the term aqueous. So here it indicates that sodium chloride is dissolved in water and it's turned into its individual ions. Same thing for the silver nitrate. You guys pay attention for the charges. You need to look at the polyatomic table. The NO3 is negative charge, the silver is positive charge in there, okay? That's why they balance each other. And then you have the silver chloride. The silver chloride is a solid, so chlorides accept silver. So silver chloride is solid. So solid remains solid. It does not dissociate into its individual ions, so it's going to become a solid. Plus the sodium nitrate, look at the table above. The sodium nitrate is going to change into its individual ions in there. This is going to be the NO3 negative aqueous. So this is a representation of the total ionic equation. So in total ionic equation, if you have ionic substances, these are going to be represented by their individual ions in the solution that they form in the solution. And then now we're going to do the net ionic equation. For the net ionic equation, we are going to look at the total ionic equation, and we're going to cancel out the ions that are the same on both sides of the equation. So here I do have sodium, and I do have sodium in here. So these two are the same. I'm just going to go ahead and cancel those out. And then I do have the nitrate. I do have the nitrate. So these are the same again. I'm going to cancel those out. Guys, the ions that appear to be the same, we call those spectator ions. It's down here. So we call them spectator ions. So spectator ions, these are ions that occur on both sides of the chemical reaction. And these are not included in the net ionic equation. So as you can see, I'm just canceling those out. So whatever is left over is the is basically the compound that is insoluble, the material that is insoluble. This is what is left in the net ionic equation. So here in the net ionic equation, I am left with the Cl minus that is going to react with the Ag plus, and it's going to form the AgCl solid. So in the net ionic equation, only the unionized or the insoluble material insoluble material and ions that undergo changes are, as the reaction proceeds, these are represented. Okay, so only the ions that are unionized and they are unsoluble, here you go. So at the end, I'm going to end up having a Cl minus that is going to react with the Ag positive aqueous, and it's going to form the insoluble material, which is the AgCl solid. And that is the net ionic equation. So only the unionized or the insoluble material and the ions that undergo the change to form that insoluble material, these are represented in the net ionic equation. So NaCl, when I'm looking at NaCl aqueous, these compounds they dissociate in the solution to form their individual ions. So when they form their individual ions, you want to make sure to form exactly the number of atoms that they represent. So NaCl is made up of one Na plus aqueous. The aqueous is very important, plus the Cl minus aqueous. This is 1 mole of or 1 atom of Na plus and the Cl minus. The sodium sulfide has 2 atoms of sodium for 1 atom of sulfur. So I need to represent this when this is totally ionized and changed into its ionic form. It's going to form 2Na plus S2 minus, and that is going to be aqueous. Please make sure to balance the charges. Sulfur is a group number 6. is 2 minus, and sodium is group number 1, which is 1 plus. The phosphate, you look at in the polyatomic table, this is a 3 negative. So the phosphate is a 3 negative. So the sodium over here is going to be, it's a 1 plus, so it's going to be 3 plus in there. I do have 3 atoms of sodium forming for every 1 uh, phosphate ion. Okay, so I do have 3 atoms of sodium ion that are forming for every 1 phosphate ion. Now, for substances that do not dissolve in water, like for example, silver chloride, those they stay solid. Another example, sugar. Sugar is solvated in water, but stays in its molecular formula there. So sugar, table sugar, has a formula of C12H22O11. It stays C12H22O11. It does not change into its individual ions. So we said that the spectator ions are the ions that are the same on both sides of the chemical equation, and those they should not appear in the net ionic equation. They cancel out. Let's have another example. So given the following molecular equation, write both the ionic and the net ionic equations, and what is the spectator ion. So this is again a double replacement reaction. So barium chloride aqueous, barium chloride from the table above, it does dissociate into its individual ions. So barium is a group number 2, so that is going to be 2 plus aqueous plus 2Cl minus aqueous. Make sure that your charges are balanced. Now the sodium sulfate, again, it is soluble, so it does dissociate into its individual ions. So here I'm going to end up having 2Na plus aqueous plus S2 minus aqueous in there. I am forming a solid, barium sulfide, that is a solid. So this solid here will not dissociate. It's going to stay as is, as barium sulfide. So now I know that the net ionic equation should include the ions to form that solid, plus of course the ions for the sodium chloride. Now the 2 over here is for the sodium, and the 2 is for the chlorine as well. So that is going to be the Cl minus aqueous. Okay. To form the net ionic equation, so this is the total ionic equation. To form the net ionic equation, I need to get rid of all the spectator ions, which means that the ions that are the same on both sides. And by the way, they need to be balanced. They have to be balanced. So if they are not balanced, you know that you started with an unbalanced equation. So you have to balance your molecular equation before you proceed to the total ionic equation. This one is balanced though. So you do have Na plus, you do have Na plus, so we're done. What we're left are the ions that form the solid. So this is going to be the net ionic equation, Ba2 plus aqueous plus S2 minus aqueous, and that is going to give me Bas, which is a solid. Energy and chemical reactions, we know that energy is definitely involved in chemical reactions, and it can take many forms, like light, like heat. So chemical reactions that release heat as a product, these are called exothermic reactions. So if you have a reaction and heat shows in the product, then this is called an exothermic reaction. Exothermic reaction is a reaction where delta H, which is the enthalpy of the reaction, is negative. Now, when you're doing a chemical reaction, and you can see that let's say, for example, if you are combining 2 compounds together and the test tube became cold, then this means that heat is being absorbed. So you have heat released and heat absorbed. Heat absorbed is whenever the test tube becomes cold. This is called an endothermic reaction. This means that the heat is going to show up in the reactant side, not the product side. Endothermic reaction means that the enthalpy of the reaction is positive. Exothermic reaction is when you are mixing two compounds together. You touch the test tube and you see that it is hot. This means that heat is being released, and when heat is released, this means that the delta H is negative, and it is an exothermic reaction.